Hello, Math 125 students. In this video, I'm going to talk about Exam 2 studying for Math 125, and then I'm going to go through a couple old exams. In this video, I hope to do a couple things, kind of talk about how to study once again, give my bits of advice. This exam is about integrals more than anything else, so let's get right into it. So first off, rules. So if you go to the Canvas page, and apologies if you're hearing things in the background. We have I have some family over that I'm helping take care of. Anyways, so you should be here. We have the Exam 2 review outline. I have notes. I have the cover page here. You can review all of this on your own. This is what the exam is. I'm not going to go through all this right now because I just want to get into questions, but the exam covers these sections. You do want to make sure to review the 6-3 homework a little bit, or you can look back at first midterms to review that. The exam will not include 7-8 or 8-1. 7-8 is improper integrals. 8-1 is arc length, just because of how it broke down this term. But the exam is going to be 3 pages of integrals and then 2 pages from these materials. But everything in terms of integration will be there. Here's the cover of the exam. I will provide this table. And I'm providing this table because this is the table that will be provided on the final. But you're allowed to quote anything from the bigger table that I also have been giving you in class. So add whatever's not here that you want, add to your note sheet. That's it. So I'd like to do is jump right in. If I were a student, what would I do? I would review the homework. I would click through the homework and say, okay, which were the things that confused me? You don't want to be surprised when you see a question that's identical to homework and not know how to start. So you flip to the homework and say, how did I start all these? Try to do that quickly, just sort of one glance through each assignment. And then I would start working old exams. Now I thought for this video what I would do first is talk about how I'm going to quickly look through 3 exams, and then I'm going to go through 1 exam in detail. So my advice would be to get a piece of paper out. I can't show you a piece of paper here because I'm making a video. And just get out 2 or 3 exams. So right now I'm going to write in winter 2025. And just kind of for each page, if it had a piece of paper, write down, do I know the first step? I think this is a form of studying that a lot of people do naturally, but not everyone does. So let's do it. Let's click this, open. Apologies here as I reshape my screen here. Just so you can see, you go to this is winter 2015. So I'm not working through this exam. I'm just doing a tour to illustrate one form of study. And so then you see this first question. And you should think by parts. And you should immediately think what U would be. And then you move on to the next one and say, okay, I think I would know how to start that one. This one you should think partial fractions. And you should immediately think factor denominator. And then start breaking things up. So this is a great way to study because at the end of this, you'll look down at your piece of paper and you'll realize which ones you had no idea what to do, and that will help you realize what you need to study. So we go to 2B. This is a trig sub, but it first starts with completing the square. And if there's something you don't know, then you put a little question mark. But when you're doing this, don't get bogged down. I find students spend hours and hours doing this part of this question, and that's not necessarily helping you get ready. At some point we should do details, but then we have a trig integral here, and the first thing we're going to do is pull out sine of x because it's an odd sign. So we're just doing a quick tour. Okay, here's something weird. Weird, but it looks like we're going to do a u sub. U equals the square root of x. And then we're going to go from there. Arc length. So you get to 2b, there's no arc length. So you can skip. Again, that's not one of the topics. Simpson's rule could be on the test. I just wouldn't ask it with arc length. So you'd say, do I know the Simpson's rule formula? So you can make a little note to yourself. Simpson's rule, do I have that on my note sheet? Okay, let's keep going. Improper, not going to be on the test. Improper, skip. Okay, on to the next one. Temperature of an object is this, average temperature. So then you would go, okay, average value. Do I remember what that formula is? Okay, next one. A work pumping question. Work pumping. Do I know how to start that? Okay, so you can see that didn't take very long, and I kind of got a feel for what was on there and which things, I know how to start them all, but you could say, well, there are a few of those I didn't know how to start. And that would really help your studying. This also is a way to build confidence. Then you can immediately go into another one. So you can use the exam archive in this way to practice your recognition, right? So you could do this, just make notes. Once you get a handle on it, you don't have to write down every one. You could say, hey, this is a trig. It has an odd secant, so I'm going to pull out secant tangent. So the very first thing you would do is you would pull out secant 5x, tangent 5x. And you want it to, if there's any moment where you pause and are hesitating on that first step, then that's something you should look at. All right, this is going to be a by parts. You're going to have u equals inverse sine. So one of the very first things you're going to need to do is remember the derivative of that. Is that on my note sheet? Here is a weird one. It's going to be substitution. I can't spell weird. I did that wrong in class too. Substitution. Okay, I will work in more detail through the other problems and the other tests, but I just wanted you to see, okay, I need to complete the square. So if I were a student, I would really want to do this to gain some confidence that I know how to start these things, partial fractions. Just start writing down the decomposition. You could even say, do I know how to write down the decomposition? Trig sub, do I know what I'm choosing? Do I know that x equals 2 tangent of theta? So this is just something you can do quickly. Improper, you can skip. Now, if you wanted to use these improper problems to practice, you could just practice the integration piece and ignore the bounds. But I'm not going to ask anything with an infinity, so we can skip. Here's a volume. So here's an opportunity to practice a volume. So here you could do a shell problem. So that would be a place to test. If you want more practice with shell problems, you can also go back to the first exam. And then we have a pumping problem. Do I know how to set that up? Do I know that you need to label it and then do distance to the top, and then ultimately you're figuring out the weight of a slice. Okay, I think that's enough. You sort of get the feeling, but you should do this. In a matter of 10 minutes, you could go through many exams like this, and at the end you'd have a real good idea of where your holes in understanding are. Okay, so let's just pick one, spring 2016, and now we're going to go into a little more detail. All right, so let's go one by one. Spring 2016, first problem. Pause it, try it on your own, and then let's go through the solution here. I'm going to get rid of my little study tips thing. And let me get a different pen here. Okay, so when I look at this, it looks like a substitution. This is one of our classic rationalizing substitutions. So you probably could pick either thing, either the square root of x or the square root of x over 4. I'm going to pick this whole thing. That just looks easier to me. If you're following what I did in class, I said before you take the derivative, sometimes it's better to simplify, meaning multiply both sides by 4. And then square both sides. Again, sorry if you're hearing noises in the background. That's just my kids and my kids' cousins, my niece and nephew, making some noise. And then I take the derivative 32t. So this is kind of you can also take the derivative directly. We talked about that in class. This is the cleaner way. And another thing you should be doing if you've prepared well is doing things as cleanly as possible. So now let's change the bounds. If I plug in a 0 for x, I get t is 0. If I plug in pi squared here, it actually comes out really nice because it just ends up being pi over 4. And then I end up with sine of u. And then dx is 32. Oh, I was using a t. Apologies. 32t dt. And now it's an integration by parts problem. So it's t sine of t dt. I'm going to say u is t. I'm going to say dv is sine of t dt. I'm going to say du is dt. I'm going to say v is negative cosine of t. And then I'm going to put these two things together negative t cosine of t. I'm going to evaluate that from 0 to pi over 4. So as I said, you really want these things to start to become automatic. You don't want to have to stare at the problem, especially these ones that sort of fit directly into a method. This is pi over 4 cosine of pi over 4 minus negative 0. The reason it's 0 is not because of the cosine, because of that. And then this is going to be so minus minus, which is plus. Antiderivative is sine from 0 to pi over 4. And so then we have it. 32 negative pi over 4 root 2 over 2 plus, and then we're plugging, this is going to be root 2 over 2. So that's done. You could leave it like that. That's perfectly fine. You could factor out the root 2 over 2, which would make it 16 root 2. And then what would I have? I'd have negative pi over 4 plus 1. Okay, I do like when I'm making these videos for us to make it, because I don't want to make a small mistake here and get someone upset at me. So let's double check our solutions to make sure. I'm trying to talk about idea. I think we said this was the spring 26 exam. So let's pull that up in my exam archive. I meant to have that ready. Apologies. Spring 2016 exam. There we go. So how did we do? So I set it up a little differently. Let me look here. I chose the whole inside. Looks like it's better to not. But let's see if this is equivalent to my answer. So I have 4 root 2, 4 minus pi. Is that equivalent? If I multiply through, I get 4. Then it would be a plus 4 if I factored out a 1/4. And let's look back at my answer. Okay, I think that's equivalent. Anyways, so there you got to see a different approach. In this one, I chose to just use the square root. So that sort of shows you if you did that, that's great. It shows you that I don't always do them exactly the same, and you don't have to do them exactly the same as my solutions, but you need to make progress. Okay, I think we're okay there. Next one. So pause, hopefully you can do this one. This is a straight trig sub problem. So to me, this is one of these we would just want immediately know what to do. That's where you want to be. You don't have to even look at a note sheet here. This is x equals what? Now you could add things to your note sheet, but it's 3 tangent of theta. And the whole point of this, there's two things. You got to take the derivative. But the whole point is that x squared plus 9 is going to simplify now. It's going to become 9. And then there's going to be a tangent squared of theta plus 1. I skipped one step there, but hopefully I can get away with that. This is secant squared of theta. Okay, that's what's going to be in here. Some students have trouble visualizing this. So we're going to have a 9. And I like to do this in the margins. It just makes my work easier, to the 3/2. So you got to realize that's going to become 9 to the 3/2. And secant squared to the 3/2. And this right here is, let's see, the square root of 9 is 3. 3 squared is 27. That's 27, and this is going to be secant to the 3rd. Oops, sorry, I got that. Didn't realize that was visible to everybody. All right, so, and then I also need the derivative. This is secant squared of theta d theta, and then we're ready to go. This is the integral. It's 5. We just figured out that the bottom is going to be 27 secant cubed of theta, and that this is going to be 3 secant squared of theta d theta. And then if I was writing this, I would write 5/9. I've talked about this in class, that you really should simplify because it makes your life easier. Don't be scared of simplifying. I did 3 over 27 is 1/9. And then everything cancels except 1 secant on the bottom. And now we're almost done with the problem because that's 5/9 cosine of theta. And if we can draw the triangle, we're done. Now the instructions on the cover exam say you must return to the original variable and you can't do an inverse trig inside of a trig. So you will lose points if you do that. I've warned about this in class, but just an extra warning in the video. This is x over 3. This is x. This is 3. That means this is the square root of x squared plus 9. And so you'd have 5 over 9, and then you need adjacent over hypotenuse, x squared plus. Now I'm not as picky about simplifying here, but you do have to write it this way. This is going to be 5/3, 1 over square root of x squared plus 9 plus c. So to me, that's a very fast problem. It does require all those skills, but it's not one that we should be staring at a long time. Let's take a look how we do. Yep, that's it. It looks like, do I have a factor of 3 off here? Sine. Oh, I did make a mistake. Let's see if anybody spots my mistake. That's what I get for talking too fast. So I don't get full credit on this test. I made a mistake. I forgot to integrate. Huge mistake. The integral is sine. And that's what I get for trying to talk and solve at the same time. Now, when you're doing your test, you don't have to talk at the same time. Apologies for that. Good, I checked. That would have confused people. Probably confused them anyways, but I just forgot to integrate. All right. And one comment as you're doing this, you should build testing whatever you can test into your work. And that's one place a common error happens. That should be something I should have checked. All right, let's keep going. So now we're going to page 2A. So pause. This should jump out at you. It's already reduced. The power on top is 1. The power on bottom is 3. And now we should factor the denominator. Let's get this erased. And so the very next step would be to write x minus 8 over, and that looks like x squared, x plus 4. And we've done several examples like this. This might even be an example I did in class. This is a repeated linear and a distinct linear. Notice how there are 3 unknowns and the bottom variable is 3. We talked about some of these things in class. Now you cleared the denominators. This is x, x plus 4. So you can see this exam, nothing surprising, but you do have to know all the techniques. If you're fuzzy on a technique, that's where you're going to suffer. And then I talked about how if I was doing this, I would next plug in one of the values that makes things 0 here. This would give you a negative 8 equals 4b. You would get b is negative 2. I would plug in x equals negative 4, which would give me negative 12 equals 16c. So I would get c is negative 12 over 16, which is negative 3 over 4. And then lastly, I would compare coefficients. And if I was doing this myself, as fast as I possibly could, I would say the thing I need is a. And I would say a is in front of x squared. It's also in front of x, but the x squareds are easy to see. And so I would say a plus x is going to be the thing that's in front of x squared. And then I would look at the other side and I would say how many x squareds are over here? There are none. So that means that a has to be negative c and a has to be 3/4. So let me just double check that c. Something felt funny about the c when I did the calculation. No, that's fine. And now I'm basically done with the problem. So it's 3/4 over x minus 2 over x squared plus negative 3/4 over x plus 4. And this becomes 3/4 the log of the absolute value of x. This becomes plus 2 over x. If you don't know how I got that, we were integrating x to the negative 2, which becomes negative x to the negative 1, which is the same as this once you change the sign. This, the log of x plus 4 plus c, and we are done. And as I've been doing, let's double check the solutions, make sure I didn't do anything silly since you have this. Okay, that's what we have. Let's keep going. All right, what do we got here? Looks like a trig sub, but I need to complete the square. So we're going to do half the middle. Half the middle is 3. 3 squared is 9. So if we've prepared, we kind of know we're looking for this. Minus 4. Perfect. Now we're ready to go. And honestly, I think if I was doing this myself, I wouldn't even rewrite it. I would just say, okay, now I'm ready. The substitution I need is 2 secant of theta. And this was, all of that stuff was to be able to see this is what I needed. It's secant because the minus comes after. And the whole reason we do that, first we can't forget that the derivative is this. But the whole reason we do that is now x plus 3 squared minus 4 is going to become 4 secant squared minus 4. Or in other words, 4 secant squared minus 1 here. So it's going to become 4 tangent squared. Okay, now I'm ready to go. So the denominator is going to become 1 over the square root of 4 tangent squared. And maybe I should have already simplified that as well. There's going to be a secant here. There's going to be a tangent here. This is going to be, the 2's are going to cancel. I should write this out. 1 over 2. Again, when you're doing the exam, you don't have to write as many steps as I'm writing. If you get it with fewer steps, that's fine. But do write some of your work. Okay, so all that's left is a secant. That would be in your table of integrals. That's one I've allowed you to quote. Plus c. And now we're almost done. I need to draw the triangle that goes with this. So if secant of theta is x plus 3 over 2, then that means hypotenuse over adjacent. Hypotenuse over adjacent. And that means the other side has to be the square root of x plus 3 squared minus 4, which is the same as the thing we started with. X squared plus 6x plus 5. Okay, now we're ready to go. Secant is x plus 3 over 2. Tangent is this other thing, square root of x squared plus 6x. You don't have to simplify it. Done. Okay, let's double check there, make sure I didn't do something silly. Got it. Okay, let's keep going. Page 3. This looks weird. So in my mind, there's two natural things to try here. Either a substitution, which will work, it will lead to something you can do, or I recognize that there's a log in it. If you recognize there's a log in it, there's a certain technique that's good for that. And I don't know what's better, but when I think about substitution, there's no x on the outside. So I'm just going to immediately go to integration by parts because I see a log. We said this is integration by parts is good for products, logs, and inverse trig. The only problem is you have to choose a log, and this is all trapped inside the log, so there's no other choice to be made here. If you try integration by parts, you have to pick the whole thing. Unfortunately, all that leaves over here is dx, but this is not the first time we've seen something like this. Excuse me. Now when you integrate, you get x. And the biggest thing here is you have to take the derivative. You do have to remember your derivative. So the derivative is 1 over 1 plus x squared times what? 2x dx. Now let's go. That looks bad, but again, what else are you going to try here? Either substitution and or by parts, and they both work, but this should be one of your first tries. Minus the integral, now I need to put these two things together, so now it's going to be 2x squared, 1 plus x squared dx. And then you reevaluate. That's success. The log is gone. But how do you do this problem? I remember on this exam, this is one of the places students got stuck. But if you state your problem, you will know what to do. It looks sort of like a partial fractions, except the bottom is irreducible and there's a 2 here and a 2 here. So if you follow the recipe for partial fractions, the first thing you need to do is divide. So these are these things. You need to have your recipe. When you're making your note sheet, include this step. Number 1, check if the power on top is smaller. If not, you need to divide. Okay, and then the conclusion from that is that it goes in there, minus the integral, 2 times with 2 left over. And if you wanted to check your work, you could get a common denominator and make sure this is the same as this. Okay, so now we're going to log of this, 1 plus x squared, and this becomes minus 2x, and then it becomes plus because the 2 minus, and then this is actually in our table. Arctangent of x plus c. Done. Okay, let's go take a look, make sure I didn't do anything silly. Yep, that's it. All right, keep going. Trig integral, where this is even. This is in our list of methods. This is also a situation where this is odd. You have 2 options here and they're both correct. Okay, let's do the one where we pull out the even since I saw that first. Then you're going to have a secant squared. So this is step 1. And then the goal is to change everything into a tangent. All this entire problem is trying to set it up so that we end up with a secant squared of 2x. The 2x might be throwing you off. If that is throwing you off, you could do a substitution to start the problem. But let's see how far we can go directly. This does change things a little bit. When I go to take the derivative of tangent of 2x, you get secant squared times 2 because of the chain rule. That's the main change. But the rest of the problem is to change everything else into a tangent. Well, this already is a tangent, so that's good. But this one is going to be secant squared of 2x. And so I'm going to have to rewrite that as tangent squared of 2x plus 1 using the identity. Tangent squared of 2x plus 1. And so then this becomes, now we're going to do everything. So when you plug in a 0 here, you get 0. So this becomes 0. When you plug a pi over 8 in here, you get tangent of 2 times pi over 8. So tangent of pi over 4. That's a value you really should know. It's usually on the cover of my exam. You could put the unit circle on. This is one you should know. This is, I mean, you can also just think of sine of pi over 4 divided by cosine of pi over 4. It's 1. They're the same. So then you get 1 squared plus u squared plus 1, u to the third. And then you do have to be a little careful because this 2. So I'm going to move it to the other side and make it a 1/2. 1/2 du. And now we're just about done. So it's going to be 1/2 the integral from 0 to 1 of u to the fifth plus u to the third. We expanded. And this is going to be 1/2 of 1/6 u to the sixth plus 1/4 u to the fourth from 0 to 1. This is going to be 1/2 1/6 plus 1/4, which is going to be 1/2. And if I was doing this, I think what I would do, this is just cleverness with fractions, is I would factor out a half out of this because they're both divisible by 2. So I'd write 1/4 and then factoring a half. I don't know if this is better or worse now that I look at it. 1/3 plus a half. And then I would combine those. 2/6, 3/6, 5/6. So it'd be 1/4 times 5/6. It'd be 5/24. Now, if you left it like this, I would accept it. Let's go take a look. Oh, interestingly, in my solutions, I did it both ways. Notice it's 5/24 either way. All right, let's keep going. Let's zoom out a little bit. Use Simpson's rule with n equals 4 to approximate the average value of this function. So step 1 is you would be doing this. But the two numbers are 9 and 1. And the function is e to the x over x. So it's going to be 1/8 of this thing. Done. Now we're doing 4 subdivisions. Delta x is 9 minus 1 over 4, which is 2. Now we're labeling our tick marks. This is 1. This is 3. Remember, the easiest way to label your tick marks is just to write down the first thing and then just add the width. Add the width. Add the width, and as a double check, your last tick mark should line up with the end. Okay, the rest of this problem is just plugging in. And Simpson's rule just goes 1/3 times the width, which is 2. And then you plug in your tick marks to your function. So that first you plug in the 1, so it's going to be e to the 1. And maybe I should just lay this out this way. So here I'm going to lay this out with a blank. Simpson's rule says this: do 4, blank over there, do 2, e to the blank over blank, do 4, e to the blank over blank, and then do it again. This is all I want you to do, is to fill those in and stop. I don't want you to simplify. I just want you to put a 1 here. I want you to put a 3 here. I want you to put a 5 here. I want you to put a 7 here. I want you to put a 9 here, and then stop. Don't even simplify. I'm trying to save you time. So I want you to show me you can use the approximation methods. Let's take a look. There it is in all its glory. Oh, you do. Your final answer should include, because the question asks you to average the eighth, it should include the 1/8. So actually, technically, what I wrote here was wrong. This should have a 1/8 in it. All right. Find the arc length. So you're going to skip this. This is 8.1, which we will do later. Okay, then we get to this last page. We have a couple questions about work. Okay, so what do we have first? A 30-meter cable with density 1/4.9 kilograms per is hanging over the side of a tall building. How much work is done in lifting it to the top of the building? Okay, let's do that. I always like to draw the picture of the start and the end. So let's draw this rope. So here's the start. This is 30 meters. Here's the end. It's been lifted to the top. Start. End. And remember, you can label this however you want. So this is tough. As soon as I make a labeling, people think it's the right way. But I'm just going to label this 0 and this 30. That's not necessarily right. It's just a way to label it. But the moment you make that choice, then you do the following. You label in your labeling what X represents. X represents this far. And you make it into subdivisions. And here's one subdivision. And then you ask yourself how much work is done to lift that. Because that's going to end up somewhere at the top. So it's going to be lifted from here to here. So this is going to be your distance lifted. And the next question is, how much does it weigh? Or in other words, what's the force? So in this labeling, the distance lifted is X. For a given subdivision, you don't have to write this out on your test. I'm just explaining. At X of thickness delta X, we have a pattern that works no matter where you are. And the pattern is the distance lifted from start to end is going to be X, and the weight is going to be delta X, which is the thickness, times 1/4.9. And unfortunately, that's not force, that's mass. And we know this game already. The moment you saw this, you should have been thinking, oh, I need to multiply by 9.8 to turn kilograms into newtons. And that's why this comes out kind of nice. It's 2 delta X. That's where I got the 4 when I wrote this question. Okay, then we're ready to go. So it's the integral. We want to do this pattern for all X values from 0 to 30. And we're doing X times 2 dx. And we are done. So it's going to be X squared from 0 to 30. It's going to be 30 squared. It's going to be 900. And you should include units on these problems. It's 900 joules or Newton meters. Let's take a look. Oh, I did it both ways. So you can see where I've labeled at the bottom. I labeled it at the top. It's the same thing either way. Last one. A portion of the graph between here is rotated around the y-axis to form a container. The container is full of a liquid that has density 900 pounds per cubic foot. Okay, so let's draw this picture. Here we go. Y equals 3x. We're going out to x equals 1, which means this is up here at 3. And it starts full. In this setting, you don't get to choose your variable. So when you go to label a certain level, you have to label it y this way. So then you say, okay, I'm going to consider a subdivision here. But the other thing is this is rotated all the way around. So the actual subdivision is a disk. Okay, so now the following question. If you pump this to the top of the container, which I think is what it says, rotate around the axis from a container. The container is full of a liquid that has a certain how much to over the side of the container. So that means to the top of the container. This is the over the side. Okay, so this is the distance a slice is lifted. And then we need to know how much it weighs. So for a given subdivision at y with thickness delta y, we have the following pattern which holds for any subdivision like that. The distance lifted is equal to 3 minus y, and the force is equal. Now this is pounds, which is a force, is going to be 90 times, and now the whole question is, what is the volume of this thing? And the volume is going to be delta y times the area. And what's the area? The area is going to be pi times the radius squared. So now we're down to one last question, which is what is the pattern for the radius? And it's different. At the top, the radius is 1. At the bottom, the radius is 0. So I really need to know what this distance is. And that distance is x equals 1/3 of y. Whatever y is, it's a third. So you have a 1/3 of y here. And then we're off to the races. So we want to do this from 0 to 3. So we would like to do force times distance for all y values, where y could be anything from 0 to 3. And then we're doing 90 pi is going to be 1/9 y squared dy. The question does ask you to integrate, so you're going to simplify, and it's going to become 10 pi. That's what that is. And then it's the integral from 0 to 3 of 3y squared minus y to the third dy. And so it's going to be 10 pi. Then it's going to be y cubed minus 1/4 y to the 4th from 0 to 3. So that's going to be 10 pi. And then 3 cubed is 27 minus 1/4, 3 to the 4th is 81. And you could leave it like that. I would accept it like that. Let's just leave it like that since I'm just doing this video. You'll notice I never pulled out a calculator that whole time. I mean, you don't really need the calculator. It's just there for comfort. Anyways, let's see how we did. All right, that's exactly what I have. Foot-pounds. Okay, I hope that was helpful. I just went through a video. The only thing we didn't do there was any shell problem. So if you should practice shells a little bit. The way to do that would be to go back to exam 1, go to the page that has to do with volumes, and do ones that say shells. Some of them many of my exams explicitly say shells. Obtain shells. This one says use shells. So you could try that. Remember, it's all about labeling. Anyways, I can do some of those during a review. I think this video is long enough as is, but I hope that's helpful. All right.